Stanford University.
Okay, well, welcome to Lecture 17 of CS193P in fall of 2011. Today we are going to talk about iCloud. In fact, I'm going to be doing iCloud both today and on Thursday. And mostly it's going to be demo as usual, but I'm going to try and work in some other stuff in those demos too, a little bit more advanced usage of some of the stuff we did earlier in the course, and also probably just seeing the iCloud stuff, and as I go through that demo, you'll just get a little more feel for the basic way that we do things in iOS that'll apply to other things that you do. So let's dive right into it, unless there are questions to start. Okay, so iCloud. What is iCloud? Basically, iCloud is nothing more than a URL of a shared directory on the network for the user. Okay. Its intent primarily is for a user to put their documents or their data, their backups, their files from their apps, their documents out there so that on any of their devices, their iPhone, their iPod Touch, their iPads, they can access that data. Okay, that's the primary intent of it, and we'll talk a little bit about other ways we can use iCloud, but that's the main part of this. So, since it's fundamentally this URL of a shared directory, a lot of the paradigms that you're used to access files, you can use, okay? But there's also some things you have to think about because it's kind of like you have a file system that could be really slow because you're going over the network. You might be 3G or you might be out of range of a network momentarily and then come back in range and stuff like that. So you have to think a little bit about latency in the way you do things and just in general the ramifications of sharing this file, because this file exists out in the cloud and it's shared between all the user's devices, right? So you got to think a little bit about what that means too. So in order for your application to access the cloud, it has to have the right entitlements. And luckily, it is a single button click to give your applications the right entitlements. And if you probably recognize this part of the of Xcode. This is, I'm just clicking on the target of the project, and I'm going to click that button right there that yellow arrow is pointing to, and it's going to automatically fill in some entitlement information. I'm not going to talk I'm not going to talk about the details of this entitlement, but suffice it to say that you really need, there's kind of two sides of this. One is the provisioning profile that you create needs to be enabled for iCloud, okay, which it is if you're using the University Developer Program here. And the second thing is it's possible to actually have an entitlement for your app to write into the cloud to a place that multiple of your apps that you ship are all writing to. In other words, the cloud, the space in the cloud that you can write is not necessarily just tied to this one app, right? You could ship 3 different apps and they're all writing into the same space in the user's cloud, okay? So the entitlements kind of manage that hookup. But by just clicking this simple switch, you've created a simple connection. As long as your provisioning profile is enabled for cloud, this app now can write into the cloud URL, okay? So what is this URL? How do you get this magic URL? And the answer is you get it from the file manager, right? And as file manager, default manager, URL for ubiquity container identifier, nil, and I'm passing on ubiquity and container identifier nil here because I want it to just use whatever Xcode filled in the previous slide when I click those entitlements. If I had multiple apps writing to the same place, then I would actually have to specify the container identifier, and it would have to match what was in the entitlements on the previous page, which is a little advanced. I'm not going to really talk about that, but normally you're going to just pass nil here as the ubiquity container identifier, and this call is going to give you back a URL, and this URL is a place in the cloud where you can create files, okay? And if you create a file there, then you'll see it on other devices that are running your app. Normally, when you create a file that the user perceives as a document, you're going to put it in the documents directory inside this URL. So you're going to do URL by appending path component documents, right? Documents, see, exactly that word, documents. And that is kind of a special place in iCloud. You'll see that there's some other API that is going to look specifically at information that's in the documents directory in the URL versus anywhere else, okay? We'll talk about that. So NS File Manager, you can use NS File Manager. Most of the API of NS File Manager will work fine on this URL. But there's some things you got to think about here. One is it's over the network, so it could be slow. So a lot of times you're going to, if not always, you're going to want to do these NS File Manager things in another thread. Okay? You don't want to block your main thread trying to access something that's over the network. Again, you always have to think about the network might be 3G or just really slow or whatever. You have to accommodate for that. So most NS File Manager things you're going to do over a thread. There's also another thing you need to think about, which is coordination. Because you might be accessing a file that other devices from this user are also accessing, possibly even at the exact same time. So there is an API for coordinating access to a file. Okay, NS File Coordinator is the main thing there. So I'm only going to talk briefly about that coordination because a lot of times you're going to be doing stuff in the cloud with UI document, the class UI document or UI managed document, which you're all very familiar with. And it does all this coordination stuff for you, okay? All the access it does to the files. So there's not a lot to do here. So let's talk about these two classes though, NS File Presenter and NS File Coordinator. So NS File Presenter is a protocol. It's an abstraction for something in the UI, like a UI document, that presents a document to the user somehow. Okay? So since it's presenting the contents of that document somehow on screen, whenever that document changes or someone wants to write to it or read from it, the file presenter has to be notified and involved in that, in coordinating activity on that file because it is presenting the contents of that file. So I'm not going to talk about this NS File Presenter protocol because I'm going to show you how to do UI Managed Document instead, which does it all for you. If you wanted to write your own presentation vehicle for showing the contents of a file, then you're going to have to investigate it on your own. And I'll talk about NS File Coordinator in a second. But let's talk about UI Document, which is an NS File Presenter. Okay? It automatically coordinates changes to the document. Right? The primary methods, if you were going to write your own UI document, would be contents for type and load from contents of type. So that's reading and writing the contents of the document. Pretty much the rest of the management of saving, methods that you're used to, like save to URL and open with completion handler, those are all things that UI Managed Document inherits from UI Document and would automatically do the right thing and call these two methods to get the data in and out. So you could write your own UI document by subclassing UI document and implementing these two methods. There's some other stuff you might want to do in UI document related to auto-saving and kind of doing undo management and things like that. But you know, fundamentally, these are the two methods in UI document. However, if your document's data is stored in a core data database, then of course you don't want to use UI document, you want to use UI Managed Document. Okay, which you've all been using, so you all know what this does. UI Managed Document is fully iCloud capable, all right? And when you think about storing a core data database on the network and accessing it from multiple locations, there's some things to think about there, as you can imagine, right? The database might be huge, and you want to have that be efficient access, and it does that, and we're going to see how it does that. Generally, you're going to put your UI Managed Document, you know how UI Managed Document, its designated initializer is init with file URL. That URL is going to be an iCloud URL if you're going to create this document in the cloud. And so you're going to get that iCloud URL from the thing on the previous slide, and then you're going to usually append the path component documents so that you're putting it in the documents directory. And you could even put it in a directory inside that directory if you wanted, if you had different kinds of documents or something like that. It's just a URL to, you know, a directory space. But generally, we want to put our documents in the documents directory because that's what that documents directory is for. And you'll see, again, soon the API for doing that. Now, UI Managed Document, since it's managing a core data database, which you'll remember is SQLite, a SQL database, right? You would not want every time you write to it, or even every once in a while after you write to it, to upload the entire SQL database to the iCloud. Okay, that would use tons of bandwidth, might be very slow, really lots of bad performance considerations of doing that. And so UI Managed Document has a mechanism built into it, very simple one, that makes it so that you only upload kind of the basic SQL database to start, and then After that, all that gets uploaded is changes. Okay, a log of changes that are made. So I changed this attribute, I added this entity, whatever. Those changes are all recorded and sent up to the cloud as little incremental changes. And then anytime any other device wants to do something, they start out with the basic database on inside their file system, and they get the changes and apply the changes to that database locally. So they have a local copy. So over time, as the database gets bigger and bigger, each device will have its copy. Okay? But all the changes are all just coming across as these change logs. All right? Now, if you added a new device, yes, it would have to download thing and apply a whole bunch of changes to get it back up to the level that all the other people are at. But still, its performance as incremental changes are made is remarkably better. So how do you make this happen? There is a very important thing you need to do. There's a dictionary property in UI Managed Document. It's called Persistent Store Options. Okay, just an NS dictionary. And you need to set the key inside of that dictionary, NS Persistent Store Ubiquitous Content Name Key. Okay, now that key, the value of that key is just a string, and it is the name of the document. Okay, so that means a name, it might be a name that you calculate internally. It could be the name that the user chooses in the UI. You might be a little bit careful about having really wacky characters in there because it is going to possibly be a file system thing. So, you know, you might have to do some stuff there. I'm not 100% sure what the limitations are there. But it's the name of the document. It has to be unique for that document. Obviously, you can't have two documents that both have this particular dictionary entry, NS Persistent Store Ubiquitous Content Name Key, that can't be the same for two different documents. It has to be different for every document. So you can set that. That's the most important thing. You must set that. This next one, the Persistent Store Ubiquitous Content URL key, I think it's supposedly optional, but I'd set it anyway. What this is saying is this is the URL in the cloud where all those change logs are going to be put. Right? All the changes are made to the core data, and it's putting up these logs of the changes, that's where it's going to put them. That does not want to be in your documents directory. Okay? It wants to be in the cloud somewhere, but not in your documents directory. Probably in a directory that's a sibling of the documents directory, like maybe the iCloud URL / core data or / transaction logs or something like that. Okay? And this key, the value for this key, which is a URL, it can be the same for all your documents. So it'll automatically divide up this directory, whatever you're specifying here, into for each document will have its own space. Okay, so this one doesn't have to be unique per document. Okay, so that's it. You set these things, then it'll automatically, and you set these options before you call save to URL or before you call open with completion handler. Okay. Right? Remember those methods, hopefully. The things that opened or creates a document. You got to have these persistent store options set before that. And we're going to see in the demo how to do that because we're going to do this whole thing. Strictly speaking, when you open a file, a UI managed document out on the cloud, you're really supposed to look, okay, UI managed documents are stored in the cloud as file wrappers. Does everyone know what a file wrapper is? Who does not know what a file wrapper is? Okay, there's a couple people. So a file wrapper is basically the document is a directory, not a file. It's a directory. And inside the directory are all the files that make up that document. Okay? So it's just a way of having complicated documents collected into a directory. Well, when you do this little trick of the change logs, inside the file wrapper, inside the directory that your document URL points to, will be a file called documentmetadata.plist. Okay? .plist, you remember, are property lists. It's a dictionary, so you would load this thing up using NS dictionary contents with URL or whatever it is, and you'd get it back. And so you're supposed to look at that file when you're trying to open a new file and get this NS persistent store ubiquitous content name key out of that metadata.plist and then use that. But in reality, especially if you have the name that's inside this, you know, the persistent store ubiquitous content name key, especially if that's the same name as the file, a lot of times people skip this step. I'm going to skip this step for the demo just for speed, but really you should be doing it this way, okay? You should get your metadata.p list out of your documents URL. Look in there, get this key, and then set this key in the persistent store options. Okay? All right. So, and that's it. Okay? You do that, and then all your stuff you do with UI managed documents, save to URL, open with completion handler, it'll all just work. Auto saving, everything, it's all work, and it'll be updated in the cloud, and other devices will automatically see the changes. It's pretty remarkable, and we'll do this in the demo. All right, so enumerating what's in the cloud. So now you want to look out and see, well, what's in the cloud? What documents are there out there? Now, you could go get File Manager and start doing enumerate directory or contents of directory, but you really wouldn't want to do that, okay? And you kind of can see why you wouldn't want to do that, because the cloud is ever changing, okay? People are, other devices of yours could constantly be updating things. Not likely that it's happening all at the same time, but it could be. So really what you want to do when you want to see what's in the cloud is you want to issue a query with a certain predicate that says, tell me what's in the cloud. And then every time that changes, you want to get a notification. Hey, that query that you asked me to do, the answer has changed. So this is very similar to NSFetch results controller, right? You give the NSFetch results controller a fetch request, and anytime something changes in the database that would cause that fetch request to return different data, it automatically goes and gets it. Same thing here. Okay, now this is not fetch results controller, and this query is a different class, but it's the same concept, where it's going to send you notifications when what you queried is different. So here's how you create a query. Use this class NSMetadataQuery. Okay, and just alloc init it. And there's two things you need to specify. One is the scope of the search. Okay, so you're searching in iCloud, and there's two scopes. One is the documents scope, which only looks in that documents directory. And the other one is the data scope, which looks everywhere except in the documents directory. So the two of these, they're exclusive ORs of each other, okay? So, usually you're using the document scope when you're trying to present the user a list of his documents that he has in the cloud, and you're usually using the other one when you're trying to find out other data, like your core data logs and things like that will all be in the data scope. And then you need to specify a predicate, okay? Now these predicates are a little different than the core data ones, okay? You still use NS predicate, but they're a little different in that you're going to query for certain attributes, okay, that exist in the target where you're searching. So in this case, we're searching into kind of like a file system, right? URL, we're searching the file system. So here's a classic predicate that we use. This is %k like star. Now %k, I don't know if some of you have run across this doing your final projects with core data. %k is kind of like %@, except for the thing it matches has to be a key in the database you're looking into. And again, the database we're looking into is the file system here. So you can see that it matches up against NS metadata item file system name key, okay, FS name key. Okay, so now we're saying the name of the file has to be like. Like is the same as equals, except for it can have wildcards like star and %. Okay, so we're saying the file name is like star. In other words, match everything. So this would give us everything in the documents directory if we use the document scope, or everything in the data, everything not in the documents directory if we use the data scope. Now, if you had a file, if your documents, you have them have a file extension like .mydoc or something like that, then you might say star.mydoc there. Or if you're looking for a specific file, user types in something and you're looking for a specific one, you could say %k equals some specific thing. Okay, but this is just predicates. A little simpler predicates than the core data ones, okay? So that's setting up the query. That's what it's going to go look for. And it's not only going to look for it when you start this query going, it's going to keep looking to see if anything new matches this, or if stuff that used to match it no longer matches because it got deleted, and then it's going to update you. It's going to send you an NS notification. So you start and stop the query with start query and stop query. Okay, so you create it, you specify the scope and the predicate, then you start it. You can also start and stop whether it sends you these NS notifications. Okay, and using enable updates and disable updates. And probably it's a good idea to do that in your view will appear and your view will disappear. If you do it and you turn it off and your view will disappear and some things happen while you're away and then your thing reappears, you'll get an update once you re-enable updates. Okay. So here's what it looks like to sign up to receive the notifications that something has changed. This is Notification Center. Okay, we've already talked about this. We're just going to add an observer to call a certain selector, process query results I called it here. And the two interesting notifications are NS metadata query did finish gathering notification. That's the notification it sends you when it first gets off to the cloud, gets the first chunk or the first look at what's out there. And then there's NS metadata query did update notification, which is something has changed in the cloud since I gathered that original batch. Okay? Now I have these both looking at the same, calling the same selector, and because what I'm going to do in that selector is I'm going to look at all the query results. Okay? But if you wanted to, you could have them be different, and then when you get did update, you could just try and incrementally change your data structures or whatever. Don't forget when you add yourself an observer anytime to remove yourself an observer in your dalloc. This is the only thing you usually ever do in dalloc anymore. In iOS 4, you used to do a lot of stuff, but in iOS 5, this is one of the only things that you do. Okay, and that's to reserve yourself, because when you're coming out of the heap, which is when dalloc is automatically called on you, you don't want to be still having the notification center pointing to you. And like I say, it uses these unsafe retained pointers, so that's bad. So you definitely want to make sure you remove yourself. So what would the process query results look like? It would look like something like this. First thing I'm going to do when I get this notification is I'm going to disable updates, because I don't want to be in the middle of processing this and I get another update. Okay, there might be a whole stream of updates happening at once. So I'm going to disable updates. Then this is going to look a little weird. You might think, ooh, fast enumeration would be better here. And there actually is API to do fast enumeration. In other words, for NS metadata item star item in the query results. But you don't want to do it that way for performance reasons. You really want to do it this way, which is to capture the result count by calling result count in the query, and then using for I equals 0 to the result count I++, and then get each item in the query result using this NS metadata item result at index method. Okay? So when you do a metadata query, the things that you get back are these NS metadata item. Now, a metadata item includes, different information in there about the thing you queried for, URLs. One of the obvious ones is the actual URL. So you call this method value for attribute. That's how you get an item out of the NS metadata item. And the one we want is NS metadata item URL key, which will give us the URL of the item that appeared or was already there in the iCloud when we do the query. Okay? Now, once we have that URL, we start doing something with the URL. So if we queried for our documents, here we might be adding documents to some list in a table view, or removing documents, or resetting our list of documents, whatever. One thing to be very careful here, though, is that these are URLs of files. Okay? You do not get URLs of directories here. And your UI managed documents are file wrappers. They are directories. So you are going to get URLs of the things inside your file wrapper here, which can be quite confusing. So what you're going to want to do then is have some code that strips off all the stuff past the end of the document name, right? And it's easy to find the document name because you're just going to look in, build your iCloud documents URL, and then add the name of the file. That's the package. And you also might want to think here that you're going to have to unique these, because there might be 4 or 5 files in a typical document wrapper, and you don't want to add, process that document 4 or 5 times. You just want to unique it, and only, if 5 files come back in the query for that document, you're just going to process the document once. We'll show that in the demo. Okay, question?
Why do you not want to do fast enumeration?
So the question is, why do I not use fast enumeration here, and why do I do this for I equals 0 thing? And it's performance considerations. The way the fast enumeration works if results are coming in, can take a very long time, okay? And I'm doing this in the main thread. Some people have argued, which I can understand, go do this processing in another thread, okay, and let it take a long time. But if you do this in the main thread and use this mechanism, it'll only give the results it has that are here. It's not going to block waiting for results that keep coming in along the way. This whole mechanism is not built just for iCloud. It's also built for like Spotlight. You ever use Spotlight searching? You know, it's just constantly giving you more and more results as you as it gets them. And so if you're trying to enumerate through them and they're constantly changing, that can be a performance hit. Whereas if you just say, give me 22 that are there right now, and I'll go through those 22.
Then what does disable updates do? I thought that.
No, disable updates and enable updates, that's about the notifications, okay? That's not about the data coming in. The data is always coming in whenever it's available. But disable and enable updates is whether those NS notifications get sent to you. In other words, whether this method gets called. Okay? So that's it. So that's how you enumerate what's on the cloud and see, always watch what's happening out there. So now let's talk about coordinating changes. Okay, so this is anytime you're going to use NS File Manager to access these files that you find in the cloud. Now again, if you're using UI Managed Document, opening and saving and all those kind of operations, those are UI Managed Document things. It does all the coordination. You don't have to do any coordination for those. Okay, you do not have to coordinate open and save, things like that. But if you do something like you want to remove a document from iCloud, and you're going to use NS File Manager's remove item at URL, for example, you need to coordinate because someone else, some other device for that user might be have that file open, and it needs to know, it needs to be involved. So one thing about any of this access that you're going to do coordinated, it has to be done outside the main thread, okay? Because these things could take a while to get all the coordination to happen. If there's multiple devices going right now for this user, it could take time. So here's what it looks like to do the file coordinator. You create a file coordinator, use alloc init with file presenter. Now, the file presenter argument there is if you are a presenter, like you're the UI managed document and you are going to do some coordinated thing, you don't have to be involved in the coordination because you are the one asking to do something to the file. So that's why you specify yourself. Here, if we're like removing a file or we want to read a file out there, we are not presenting the file. We're just reading it or deleting it or whatever. So we're going to specify nil. In other words, all file presenters are going to be involved in the coordination here. Anybody who coordinates this file is going to be involved. Who presents this file, rather, is going to be involved. So then there's just a bunch of methods like coordinate reading item at URL. You pass it the URL you want to read. You pass some options, which you can go look up what the options are. You pass a return value to get any errors. And then you pass this block, okay, that takes a URL as the argument. That URL that gets handed to your block, that's the URL you need to use to read or write or do whatever you're doing. Okay, that URL is a coordinated URL. Okay, you don't know what the URL is, you just know it represents the same thing you passed in, but it could be a different URL, and that's the one you want to use here. Okay? So you would then do your NS File Manager, remove whatever at URL, new URL, or URL to use. Okay, not your original URL. Does that make sense? So you can think of the coordinator as checking with all the other file presenters out there, make sure it's all good, maybe locking the file, getting them to close their file if you're trying to coordinate for deleting, for example, which is one of the things you can do. And then once everything's set, then they'll give you a URL to delete that thing. Okay? Now, you might delete it, and then all the presenters might have still a copy of the old URL with pending instructions to shut that thing down. Okay? That'd be a better performance to do that. It kind of depends on what operation you're doing. This NS File Coordinator reading options, there's also NS File Coordinator writing options. For example, one of the writing options is writing for delete. I'm going to delete this file. So tell all the other presenters this file's going away. So there's about 5 or 6 different coordinate reading, coordinate writing. You can even coordinate multiple reads and writes at the same time. Okay, there's like coordinate reading item at URL and writing at URL. So you can go look at the file coordinator stuff. And you do need to do this if you're going to access a file, any file, in the cloud. Okay? Unless you're accessing it through UI Document API. Then it'll do the coordination. Okay, and we'll do this in the demo too. Okay, document state. So you all know about UI document state. It's more important to pay attention to the document state than it was in your assignment, for example, when you were all your document was local. In fact, there's two states especially that are more likely to occur now because of this latency and shared access. One is editing disabled. Okay, your state could go into the state editing disabled. And another interesting state is in conflict. All right, so let's talk about those. The saving error state also can happen more often. And when you go into the saving error state, you might want to try and resave again. Okay, you tried to save, you got a saving error. Maybe it tried to save over the cloud and the network disconnected in the middle or something like that. Couldn't save it, or someone else was saving at the same time, and so often you just want to try again. And yes, there's a way to find out what the error is. It's in the document API. You can go look at that. But let's talk about conflict and editing disabled. So what is this this document state in conflict? Okay, well, imagine that I have my iPad here and I have my iPhone, and I go and I have a document that's in the cloud, and I go out on my phone and I make some changes to that document, okay, and I save it, but I don't have any 3G service. I'm out in the middle of nowhere. It couldn't actually update to the cloud. Okay, I forget about it. I come back to my iPad, I make some other changes to that document, okay, and I save it to the cloud. Okay, this one, let's say, is connected to the network. Boom, it goes up to the cloud. Now this phone, I drive back into the network service, and boom, it tries to update the cloud. Those two documents might conflict, okay, because you made two different edits that went up to the cloud, one before the other, and now it's conflicting. So what do you do in that case? What happens is iCloud keeps all the versions, keeps the version from the phone and the one from the iPad 2, and it will set your document into this state of being in conflict, and you have to resolve that conflict. Now, how do you resolve that conflict? It's going to give you an API to look through all those versions, okay, and figure out if you want to merge the changes from two versions, or you just want to take the latest version. You might get the user involved, possibly, although you should try not to get the user involved. If you can figure out how to resolve the conflict yourself, you should. And if it's core data, you got a lot of tools to do that, which you'll see in the demo, where you can basically merge changes. Core data knows how to merge changes. As long as you're not changing the same attribute on the same object, it can do merging pretty well. But if you have a more complicated document, you might have to semantically understand what the two changes were and how to resolve it. Once you've resolved all the conflicts, you should delete all the old versions, the versions that you're not going to use. Keep only the current version. Well, first you're going to mark all those old versions resolved, and then you just delete them, okay, because they're just wasting disk space. Like the one from the phone, if you're not going to use it, or if you've already taken the changes out of it, you can now delete that old version. So we'll see in the demo briefly. I'm just going to give you kind of a simple conflict thing, which is just going to take the newest one and forget all old changes. But this is a new thing that you didn't have to do before with your document state. And then the editing disabled state, you got to pay more attention to that because it's going to be less transient that your editing is going to be disabled. And basically what you want to do here is, if the user tries to save a change and editing is disabled, don't do it. Okay, don't make the save. Now, you got a choice then. You could put up an alert to the user saying, sorry, can't save right now. Depending on what your document is, you could maybe, do a perform after delay and try again in 10 seconds. Okay, a lot depends on what your user experience is and what you think the user would expect if the document is currently in a state where it can't be edited. Okay, now this state is not going to last for hours or probably not even for minutes. It's usually going to be seconds. But still, you should pay attention to editing disabled document state. Now, the document can move in and out of these states, as time goes on when other devices are used. So you really need to be signing up to watch the document state. And I'm going to show you how to do that in the demo, so that when it moves into one of these states, you get notified and you can do something about it. Okay, it's just an NS notification, anything else. A couple of last things about iCloud before we get into this demo. And this demo is a long demo. This is a 2-day demo, so you're going to see a lot of stuff in here. One is moving a file to and from the cloud. All right, so I think it's a pretty good UI, for the user, for most documents, if you truly have a document-based app, to allow them to specify whether they want their document on the cloud or not. Okay? They might just want it on this device only. I only ever want this document on my iPad. I never want it on any of my other devices. Okay? So how do you do that? And the answer is there is one method in NS File Manager that lets you move a file from or to the cloud. Okay? Back or forth, you choose which one you want. One thing about this method, always do this outside the main thread. Not just because it might take a little while, it probably won't take that long actually, but the main reason is that file presenters are going to have to be involved here, and so they might be on the main thread, and you don't want to get into a deadlock where this thing is running the main thread, and it needs some file presenter to do something, and that runs on the main thread, and so now nobody can continue. Okay? So always do this outside the main thread. So here's an example of doing this. And this is kind of fundamentally coordinated, so you don't actually have to do this within an NS file coordinator because you're talking about moving the entire document here. One thing that's new here, the very first line there, dispatch async. So you're used to doing dispatch async, and I'm going to introduce today a new way of doing dispatch async, which is instead of creating a queue and dispatching to it, you can ask the system, just give me any old queue with a certain priority. Okay? And it'll give you a queue. And you don't have to release that queue. It's kind of a shared global queue. It's still a serial queue. And this is what the API for that looks like. You say dispatch async, dispatch get global queue, and the argument there is the priority. And so there's the default priority, there's a background priority, there's a low priority, and there's a high priority. Okay, those are your 4 choices of priority. And there's some flags there. It's always 0. It looks like, yeah, it didn't miss anything. Yeah, so anyway, you call this, and you'll get a queue that you can post things. It's guaranteed not to be the main queue, right? So it's some other queue. So this is really, I didn't show you this before because I wanted you to learn how to create your own queue, you know, dispatch async to it, release it later, et cetera. But this is really how you do it if you just want to fire off a piece of code onto another thread. Okay, question? So the question is, if you're doing multiple document edits, would you have to worry about this blocking? And no, you wouldn't, because these are, well, we'll talk about that after, but basically these are serial queues, and what you're doing here is moving this document, right, from one place to another. So that's all going to happen in this one line of code, this set ubiquitous, and yeah, it might talk to file presenters, but you're not going to have any other file presenters who are running in a random queue. You see what I'm saying? They're either going to run the main queue or kind of in their own dedicated queue, most likely the main queue, because they're UI, right? They're presenters. They present in the UI, so they almost always run the main queue. So yeah, so that's the answer. No, you're probably not going to have that problem. So here's an example of I'm moving an item from my local storage, my sandbox, to the cloud. Right? So I have this local URL, probably points to the document, something in the documents directory in my sandbox. And I get the name of the document by getting its last path component. I get the iCloud URL by taking my documents URL, which is just ubiquitous, you know, the thing we did on the very first slide, with documents appended on the end. I put the name on the end of that, right, by appending path component. Now I have 2 URLs. I have this local URL and I have the iCloud URL. And then I just call set ubiquitous yes, which means yes, I want it to be ubiquitous. I want it in the cloud. Item at URL, that's where the thing currently exists. Destination URL is where in the cloud I want it. And then, of course, it'll report errors back to you. Okay, simple as that. And you can do it the other way around, too. You have something that's in the cloud. You can say set ubiquitous no. The item at URL will be a cloud URL. The destination URL will be some local URL, and they'll move it. Okay? So you can move things back and forth. These probably feel to you like, oh my gosh, this is going to be slogging a whole bunch of bits over the network. You got to remember that the cloud is very optimized. A lot of stuff exists in the cloud and on your local disk. Okay? Kind of you have a mirror of the cloud, or at least the interesting stuff that you've been looking at in the cloud, on your local disk. So when you do this, just a quick message goes to the cloud that says, take this off the cloud. And then copy is local, right? Just because all the information is local. And then the cloud does a couple of things probably. It goes out and sells other devices. Oh, this thing is no longer ubiquitous. So they all stop seeing it in the cloud, right? Their queries, their metadata queries say, that's not there anymore. Also, at some point, maybe not right away, it's going to delete the stuff from the cloud to make more space because the user has limited space, right? But all this is not happening synchronously, right? It's all kind of asynchronous. It's a very kind of sophisticated mechanism to make this all go as fast as possible, right? Sharing a file via iCloud. Now, I've only talked here about the fact that iCloud is used for a user to share their own, his or her own files amongst all of that user's devices. But there is actually a way to get a URL that you can send to someone else to say, hey, look at this file in my cloud, okay? The one thing to think about this is that you can only do this with files. So it's not likely you're going to say, hey, look at this UI managed document, okay? Because a UI managed document is not a file. It's a file package with a whole bunch of stuff and all these change logs and a SQL database and all that stuff. So this is more, you know, you might be sending a PDF that you generate or something else that you store in the cloud, and then you send someone a URL. It's only temporary in that the URL you get is not good forever. Eventually it'll expire, and then it won't work anymore. And here's what the API for that looks like. Very simple API. So you've got some URL in the cloud that you want to share, and you just call URL for publishing ubiquitous item at URL, and you give it a pointer to an NSDate pointer, and it'll give you back the date when it expires. You can pass null there if you don't really care when it expires. And you also get your error back. And this shared URL that you get back will be like https:// something iCloud.com/blah, blah, blah, something unreadable. But you give it to someone, and when they open it up in their browser or in their mail or whatever, it'll show them that document. Okay? Does that make sense? So it's kind of a fun way to share documents with other people to some extent. The last thing I'm going to talk about is the essentially NS user defaults of the cloud. Okay? I show you this last because this is very limited storage. NS user defaults, we always say, is for little things like preferences and stuff like that, and that's exactly true here. But here, it's going to be somewhat enforced. Okay? You're only, I believe the limit is 64K bytes. The whole store can't be more than that, and no one key value can be more than that, I believe. You access it, though, just like NS user defaults. Instead of saying NS user default standard user defaults, you say NS ubiquitous key value store default store. Okay? So same thing with shared instance and all that. And then you have set object for key, set int for key. It doesn't have quite all the same stuff that NS user defaults has, but you can do all the things NS user defaults can. You might just have to convert something to an NS number or something like that. It's still all property list based. You still have to do synchronize. Synchronize is a little different, okay? Because synchronize does not mean block the current thread and go write this out on iCloud and when it's done, continue. That would be ridiculous. All synchronize says is this thing has changed. And when you get a chance, could you please update this on the cloud? Now, that get a chance probably is going to be within the next minute or so, okay? But it could easily be 30 seconds or a minute. Or if you drove out of network range, it might be tomorrow when you come back into network range, okay? So it will always eventually get there, but this is networking, and it's also, this is not something where it's like you play a video game back and forth between your devices by updating this key. I mean, this thing could take quite a long time to update on both sides. So synchronize just means, and actually synchronize means both ways too. So synchronize means, hey, I'm interested in, I'm going to be looking in the default store for things, so you might want to go to iCloud and get them for me. And it's also the other way around, which is I just changed something, so you might want to tell other people what's going on. And also remember that the change has to go up to the iCloud, and then it has to be notified down to the other devices too. So that's yet more time. So how do you find out when your key value store changes, right? So you got this default store or whatever, it doesn't immediately, you don't immediately get the latest changes. It comes down a certain time. And how do you find out? NS notification. And the notification you signed up for here is called NS Ubiquitous Key Value Store Did Change Externally notification. And you just sign up to get that. And one really important thing to get right here is, you see the object at the end of add observer? That is that default store. NS Ubiquitous Key Value Store default store. If you say nil there, and some people get in the habit with NS Notification Center, they just always pass nil there. In other words, give me all the notifications from anybody. But if you don't pass that NS Notification Key Value Store or NS Ubiquitous Key Value Store default store right there, then your app doesn't even really know to go try and fetch this, okay? Because you never created the default store, so it's kind of like just sitting there nil. So you definitely need to pass that. Then when you get a notification, remember notification methods look like this one, where the argument is a notification. That notification's user info will tell you which keys changed and also why those keys changed, whether it was something changed on the server. This was the initial sync that you got by this is the first update that your app has gotten. Or quota violation is some key value tried to be written and it's full. The 64K has been exceeded. All right. And then you get the keys that changed as well. So that's an array of the keys. Another thing to notice here is this does not get called if you change the key. Okay? This only gets called if some other device changed the key. So you need to do some work on your end if you change your keys and you want it to appear in the UI. You need to reload your table view or redraw or send your own internal notification to get things to update, okay? This does not get called if you change the key values, only if other people do, other devices. All right? Okay, so that's all the slides. A lot of this will be elucidated via the demo, as usual. And this is a big old demo because it's not just iCloud stuff. I'm going to talk about some other stuff along the way. But what I'm going to show in this, what I'm going to do for the demo is, remember we have Photomania from 2 weeks ago, or 3 weeks ago, I guess, where, let's see here, let's even run Photomania. Well, I'll run it in a second, but Photomania, you'll remember, just comes up and it goes to Flickr and gets a list of recent photos and shows you all the photographers who took them. Remember that? And you can click on a photographer and it'll show you the photos associated with that photographer. So what we're going to do is we're going to make those fetches be documents. All right, so I'm going to have these documents in the cloud, and each document is going to be a fetch of photographers. And then I'm going to actually make it so I can edit those by deleting photographers that I don't like. And so then I'll have multiple documents, and then we'll show how when we change either the list of documents or change what the fetch results were, it'll automatically update on the other devices. So I have 2 iPads here. I don't know if we'll get to this today, maybe. But as I change things, you'll see the other one changing. Okay? So, yeah, and we'll do all kinds of things, deleting documents, handling file version conflicts. We'll do the key value store. Along the way, I'm going to show you some other things that aren't iCloud related. For example, I'll show you how to do this get me a random queue of a certain priority thing. Notice I'm going to build a generic iCloud document handling view controller. Okay, so even though this list of documents is going to be Photomania photographer fetches, nothing in the view controller I'm going to create to show the list of documents and click on them is going to have anything to do with Photomania. Totally reusable class I could go throw in another app. Okay, so we'll talk a little bit again about genericness and just building APIs that are generic. We'll be doing a bunch of notifications. Obviously, you got the idea. There's a lot of those things here. I'll talk to you a little bit how to make your prepare for segue in your table view nice and generic and reusable in a lot of circumstances. I'm going to talk about migrating your core data schema to a new schema. So let's say you developed your app, you shipped it to your customers, and now you want to add an attribute. Okay? Well, you know right now in your development what you do is you delete the app off of your device and then start again with a fresh database. Well, you can't ask your customers to do that. Instead, you can create a new schema that's a superset of the previous schema, and core data will automatically migrate the old database to the new schema, which is pretty awesome. I'll show you how to do that. We're going to use Ask or View Controller again, just in case you didn't really quite understand that modal view controller. We'll use it again. And we're also going to show how to edit a table view, specifically how to make a table view so you can delete rows. Okay? Then that's how we're going to edit our document, our iCloud document. We're going to delete things out of it, and we're going to see that those deletions will happen on other devices. Okay? And just to finish up here, coming up Thursday is going to be all demo. I'm going to continue this demo. And then Friday, we have an OpenGL section. We're going to post on Piazza what that's going to be about. And so here we go. Any questions before I dive into this demo? All right. So here is Photomania. Okay, this is exactly what I posted on the web. Just to remind you what it does, I'm going to go ahead and run this on my device right here. This is my iPad. So it runs, and it just makes a fetch. Here you can see that it's fetched from Flickr. These are all photographers, and when I click on a particular photographer, then it shows me all the photos by that photographer. Okay? And then if I click on it, then it shows me the photo. Okay? So what we're going to do is imagine this storyboard for this thing. We're going to have another view controller before this, which is a list of fetches. Okay, a list of each fetch is going to be a managed document. Okay, so the first thing I'm going to do in the demo here is build that view controller, this generic show me a list of documents in the cloud view controller. So let's do that right here by just going over here to our object library. I'm just going to pull out, actually it's going to be a table view controller. All right, so let's pull out this table view controller right here. I'm going to make this table view controller be the root view controller instead of this thing. I'm going to make it be this thing. All right, so that's root view controller. So I've kind of disconnected the rest of my app for now. We'll obviously reconnect it when we click on a document. We're going to do a photographer fetch and then go back in here. But for now, we're just going to disconnect it because we just want to show our list of documents on iCloud. So as usual, when we add a new table view controller, the first thing we're usually going to do is to create a new class for it. So I'm going to go over here and create a new UI view controller subclass. We'll call this document view controller. Okay, because that's what it's going to do. It's just going to present a list of documents in iCloud. Put it in the normal spaces here. So there's that. Before I forget, we obviously want to go here in the storyboard and select this table and change its class to be the document view controller. Let's go in our code. This is the code we got. Let's, as usual, delete a whole bunch of stuff here just to make this easier for you to see what's going on. I'll be putting back some things like view will appear, but let's keep the rotation here, and as usual, we'll allow this to rotate to any orientation. The number of sections is going to be one section, one big section, so I'm going to delete that. We'll keep number of rows in section. We'll implement that. We'll implement cell for row and index path. We're also going to keep this method right here, which is commit editing style. That's how you make an editable table view, so we're going to keep that one. We're not going to make our rows movable, though, so we'll get rid of those. And we're going to use segues instead of did select row and index path, so we don't need that. Let's see, what else we need to do here. Let's go back to our storyboard here and look at our cell type here. So we have this cell. I'm going to make this cell be subtitle, and we'll call it, what is this? This is a document cell, basically. And we got to match that up with our code. Call that right here, document cell. So these are all things hopefully you're familiar with. We're just creating basically the infrastructure of a new table view controller. So the next thing I'm going to do is create my model for this view controller. It displays an array of documents. So I'm going to have my model be an array of documents. Okay? I'm going to have it be private. Okay? I could make this public actually, but I'm going to make it private for now. I can always go back and publicize it later once I'm happy with whatever my model is. Sorry about that. My mouse clicking here is good. So this is just going to be a property, non-atomic, strong, NS array, documents. Okay, this is an array of NS URLs. Okay, so we need our synthesize here. Now, let's go ahead. Now we have our model. We can implement our table view data source right here. So what's the number of rows? That's just going to be number of documents count. Okay, simple. And then configuring the cell, also easy. We're just going to say that first let's get our NS URL, the URL that was selected in the table, and we'll just get that by doing self.documents object.index, indexPath.row, right? Our model is an array of NS URLs, so we'll just get the one. And then let's have our text label text be, let's say, the URL's last path component. So I'm going to have the URLs of my documents be such that their last path component, this is probably okay design, but for the demo it's really easy. We'll just have that always be the name of the document. That we can always get at the document's name very easily by doing that. And then the other thing I want to do is I want to override my setter of my model to update, to reload my table view. Okay, that's something that in general is a good idea. I also want to make sure that anytime the documents are set, I want to sort them. Okay, so I always want my documents alphabetically sorted. And this gives me an excuse to take a little diversion from iCloud and talk about how we use a block in an API, right, that is not related to GCD or anything like that. So here's a way that if you have an array, you can get a sorted version of the array. So I'm just going to say the documents equals the documents sorted array using comparator. And you see this comparator right here? That's a block. Okay? And so this block has to return an NS comparison result, which is either NS ordered descending, NS ordered ascending, or NS ordered the same. And it just takes two objects. Now I know my array is an array of URLs, so these two arguments are going to be URLs. So this is what this is going to look like. Comparison result, NS URL, URL1, and NS URL, URL2. Okay? So I have to make this block. Oops. And what do I need to do in here? Well, this block returns an NS comparison result, so I need to compare these two URLs and return an NS comparison result. Well, I want these URLs to be ordered by their last path component, right? Because that's the title of these URLs, that's the title of these documents. So I'm just going to return URL1's last path component. In fact, I think there's even a better way to do that. Yeah, okay. Case insensitive compare, URL2's last path component. Okay, so case insensitive compare, it just compares two strings case insensitively and returns a comparison result, which is exactly what we want right here. So by doing that, one line of code or two lines of code, boom, and sorted this array. Even though it's an array of URLs and how do you compare them, blah, 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 we just used a block to reach in there, get the strings of their last path component, voila. Okay, so now that I have my documents, I'm going to do another interesting thing here. A lot of times we would say if documents does not equal documents, then set the document, right? Just because we don't want to do extra work. But really here what I want to say is even more than that. I want to say if the documents is equal to this documents that was passed in, actually if it's not equal to, right, then I'm going to set the documents equal to documents, and I'm going to update my table view. Okay, so this way, if I pass the exact same list of URLs, okay, even if the URL objects themselves are different, even if the arrays that I passed in were a different order or whatever, once I sorted them, if it's the same list of URLs, then it's not going to do any extra work. Okay, so sometimes, I just wanted to point out here that this is not always just underbar documents does not equal documents. Be a little careful there. think that's all I was going to do there, yeah. All right, so now the next thing we want to do is populate this documents with this NS metadata query of what's in the cloud, right? So let's do that. We need a query for that. So I'm going to create another property here, which is an NS metadata query. I'm going to call it iCloud query. And let's synthesize that as well. All right, so we have this thing. I'm going to lazily instantiate this thing, okay, this property right here, so that whenever it gets asked for, it gets created, because I'm only ever going to create one of these queries, and I'm just going to start running, and it's just going to always be doing updates. So here is the getter for iCloud query. And so if I haven't created it yet, then I'm going to create it. NS metadata query alloc init. And I told you that you need to do two things with your query. You need to set the scope of the search and the predicate. So let's do both of those things. iCloud query. The search scopes, we're only going to look in the documents directory here, because all I'm going to be showing is my iCloud documents. That's pretty obvious. NS array with object. NS meta, sure I get this right, metadata query documents, what is it called? The ubiquitous document scope. So this tells the metadata, I want all the documents in the cloud. That's what this ubiquitous thing, ubiquitous, in case you don't know what that English word means, it means everywhere. Ubiquitous means everywhere, okay? So that's what we use to specify cloud. So then we also need our predicate. And this is going to have a simple predicate. I'm just going to find all my documents in the cloud. So that's predicate with format, %k like star. And the %k is the key that I want to match against star. And that is going to be our metadata item file system name key. Okay, so now we have this query, and we can just return that. But we still need to start this query running. Okay, so I'm going to do that in view will appear. So if view will appear happens and the thing is not running yet, I'm going to start it. And I do that by saying this: if self iCloud query, oops, sorry, this is a property, self.iCloud query dot, if it has or is started, not. Okay, so if the cloud query has not started, then I'm going to start it. Okay, now starting the query does automatically enable the updates. Okay, so you would think, don't need to say iCloud query enable updates here to get those NS notifications start happening, but I do, because what if my view controller disappears and then reappears? Well, in that case, this query would have already been started, so this will not happen. This won't be executed. So we want the updates to be re-enabled, because in view will disappear, I'm going to be a good citizen to my app and disable updates. Okay, so I'm going to stop those notifications happening when I'm not on screen, because it's kind of a waste of time. All right, so the NS notifications are coming in. So how do I receive them? Well, I have to add myself as an observer to get those. A good place to do that is when I'm lazily instantiating the iCloud query, the very first time I do. And we do this using NS Notification Center, Default Center. I just say add observer, and the observer is going to be self. I'm going to call my selector, what did I call it? Process cloud query results. So this is the method that's going to get called each time it updates. And the name of the notification is NS metadata query did finish gathering. And we only want to receive that from our, we're here so we can do this, iCloud query. We could say self.iCloud query there, okay? So that's getting the initial results from us, and we want to do the same thing to get updates as things change in the cloud. And that one's ns metadata query did update notification. Okay, so it's going to send this method initially and every time it changes. So what's that method look like? Looks like this. Process cloud query results. It's an NS notification method, so this always takes a notification as the argument. Okay, so how are we going to process this? Well, actually, before I do that, I added myself an observer. So one of the first things I'm going to do is go down here in dealloc and remove myself. Oops, remove observer self. Okay, make sure I get removed when I get deallocated. All right, so we've got to process this cloud query results. How's that going to happen? This looks a lot like the code that was in the slides. We're just going to disable updates. Then I'm just going to say, let's create a mutable array here to hold my new documents that I'm going to be getting. So I'm just going to wholesale get all the documents and make a whole new documents array. So we'll do that. I'm going to get the result count by asking my query for the result count. And then I'm going to do my I for int I equals 0, I is less than result count, I plus plus, to iterate through them. Each one is a metadata item. And we get that by going to our query and saying, give us the result at that index. So now I have the item. I need the URL that's in the item, which looks like this. Item, value for attribute. It's called ns metadata item URL key. Okay, so now I have the URL. Now I got to do this file package business, because I'm going to get a URL here of a file that's inside my document. Probably that document metadata.plist that I talked about in the slides, that's probably the file that I'll get, but there could be other files in there. The implementation of the internals of UI managed document is not our business, so there could be multiple files in there. So I really want to say URL equals self file package URL for cloud URL, and then I'm going to have to write this method. And this one I decided to write ahead of time here, save some time. But what it basically does is first of all, I declared my iCloud URL method, right, that returns this URL for Ubiquity container. Then I also created a iCloud documents URL, which is the same thing with appending the documents. Everyone understand that? And so then all I do is just make sure this is actually an iCloud document URL. And then I just go in here and grab all the components of the URL up to the first thing in the documents. Okay, so I'm getting top level things in the documents directory. You can look at that code later if you like. And so now I have this URL, so I'm just going to add it, okay, to this documents, this local documents that I created right here. And that's it. So I'm going to set the documents, my self.documents. So I'm setting my model here. That's going to automatically update my table. And now I can enable my updates back on. Okay? Everyone cool with that? All right, so that's pretty much all we need to do to get the query working, except we need to enable our entitlements. Okay, remember I talked about enabling entitlements? So I'm going up here to our project. Here's the target. Okay, I'm in the summary tab right here. And if I scroll down to the bottom, you can see here's the entitlements right here. And I'm going to click to enable them. It's going to fill in these entitlements here for the key value store and the containers. By default, it's going to use your app's extended name, unique name. Makes sense? So that's all I have to do there. You'll notice that it actually created a file here, photomania.entitlements. This is a little plist. I like to usually put this down into supporting files or somewhere out of the way. So that's it. So assuming I haven't forgotten anything, I believe that this should work. So let's give it a try. Let's see. Now I put some documents in my iCloud, so this would actually do something. So we'll see if it finds them. One thing about doing a networking-based demo, you know, the network, and hopefully, oh, it worked. So no caveats necessary. So here's my, this is my document view controller, and it's found these 5 documents. Now, I can't click on them because we haven't set up any segues or anything like that, but you can see how it has set this up. Now, one thing that's interesting here is that it should notice if one of these gets deleted, right? Because we have set up the URLs and all that. So let's try that. I have another iPad over here, which I can show you. So there's another iPad. So I have another version that's a little more advanced. It's showing the same thing from the iCloud. And so if I delete one over here, so let's say maybe we'll delete this one. Hopefully, it should update over on the other one. And again, this is happening over the cloud, so it takes a little while to come up, come back down, but voila, there it is. Okay? So now we're talking about keeping in sync the high-level list of documents that are in the cloud. Okay? The next level we need to do is be able to keep in sync the contents of the documents. So these documents over here have data in them. And if I went into here and delete something, right, like this, then if I could open it up over here, which we haven't done the segue yet to open these documents up, you'd want it to delete over there. So that's what we're going to do on Thursday. Okay? Show how to keep the contents of the documents instead of just having it so that when we delete them at the top level, it does it. Okay? So that's pretty much a good stopping place right there. And we'll continue this on Thursday. I'm here today. If you have any questions afterwards, feel free.
For more, please visit us at stanford.edu.